Hey, in this video, we're going to be talking about boxing and unboxing in Stream API. Confusing, right? Not confusing. It's very straightforward. Trust me, watch the first 10 minutes, understand what actually boxing and unboxing, what actually auto boxing and auto unboxing means in Java. In case you forget them, then do practice the same with Stream API. Learn about some beautiful interfaces that not Spring. We're not talking about Spring Framework. We're talking about Stream API. So we're going to be learning about some beautiful APIs provided by Stream API in order to handle the primitive types or the primitive type values like int value, float value, double value. We have different interfaces comes with the Stream API. We're going to be exploring them. Also, we're going to be learning a little bit about the reduce method and some other things also in this particular video, which is going to help us to learn the next part of the video, which is the parallel stream. So I think I have recorded the parallel stream video already, but I think these things are very much important just to have the foundation. Then you can jump for the parallel stream and can learn that. And then we're going to have one more video where we'll be learning about all the different methods that we have in Stream API. But before that, I want your foundation to be sharp. Okay, complete this. This will help you. All right, and hold on. Before you watch this video, if these videos are helping, make sure to do subscribe and do like this video for sure, so that YouTube can do some recommendation of this channel to the other people, and they can also do discover this channel, right? So that's it. So let's just get into the video right now, and let's just get started. All right, so before we go ahead, I want you to recap something that you might have learned in your core Java days. I want you to recap two concepts, autoboxing and auto-unboxing. There are a couple more, boxing and unboxing. So what is the difference between boxing and unboxing? What is the difference between autoboxing and auto-unboxing? These are some terms, right? I'm sure that you know about it, you are using it in your day-to-day project every day, but just want to recap these things a little bit, which will help you to understand the Stream API, some inbuilt functionality in a much better way. Okay, so let's just see an example of boxing. What do you mean by boxing? Let's say we have a primitive value. Let's say int I equal to 10. This is a primitive value, right? Can we convert it to a respective wrapper class type? You know that for every primitive value, we have a wrapper class available, right? For int, we have a wrapper class available called integer. So if you want to convert this primitive type int value to the respective object type value, then you need to do it by yourself. For an example, you can do something like this, integer dot value of, you can use this method, put in this I by yourself, and this value of method is going to return you an integer object. If I'm going to do command option V, and if I'm going to handle the return type, you can see I'm going to get an integer object back. Now I can just do s out of integer, and what this integer value will be, it will be 10. If you're going to run this like this, okay, you can see the output, this is 10, right? So this process is what we called boxing, right? We're converting a primitive type integer value over here to the respective wrapper class type or the object type. Okay, and we are doing it by ourselves by using this integer.value method, integer.value of method. As a programmer, I have done this conversion. So this is what we call boxing, right? But there is a concept of auto boxing. Let's say if I don't want to do it by myself, something like this. Rather, I'm just directly going to say I like this. Is it possible? Absolutely. If I'm going to run this, am I going to get the same example? Am I going to get the same output? Absolutely. And as you can see, the output is 10 right now. So what do we understand over here? Here, we're just assigning this I, which is a primitive value, directly to the object type value. But the conversion has happened internally by the compiler. Compiler has converted this I to the object type value by using the integer.value of method internally. The thing that I have done before, compiler has done it internally and then assigning that value over here. So what compiler has done internally is this. Same thing, integer.value of is a static method. Put in this I, this will be converted to integer right now. So this thing, compiler has done it by itself, and that's why what we call this a autoboxing concept. Automatically, the primitive type to the object type conversion happened by compiler. That's why this is autoboxing, right? But if you're gonna do the other way around, if you're gonna do it by yourself, this is what we call boxing, right? Memory refreshed. Okay, I'm just remembering my Java days. Okay, teaching core Java is fun, isn't it? A lot of things you will recap. Core Java is something that we want to know, we want to learn, but we don't have much time to explore. But that's a great thing that we're doing it right now. Okay, great thing. I'm gonna give you another example. Let's say, for an example, if I'm gonna remove everything, and I am going to give you an example of a day-to-day thing that you are doing. Let's say you have an array list of integer. What I'm gonna do, array list dot add of 1. Can you tell me this is an example of what? Is there boxing or is there auto boxing? Now think about this. I want to store a bunch of integer inside this array list, but what I'm adding over here is a primitive value. So if it is a primitive value, internally, this primitive int value 1, it is getting converted to integer value by the compiler, then will be added to this array list. So this automatic conversion of primitive to integer type thing is happening by the compiler behind the scene. So that's what we call autoboxing, right? So internally, what compiler is doing, it is doing this, integer value of 1. Okay, internally this thing is happening. If you're going to do it by yourself, you're converting this primitive type to integer, then adding it over here, then this is what we call boxing. If you're not going to do it by yourself, this is what we call autoboxing, right? Internally it is happening, right? So let's just talk about the unboxing approach. So what do you mean by unboxing? And what do you mean by auto unboxing? Okay. I can give you a very simple example right now. With this only you will understand. Okay, right now you have added 1 over here. It has been converted to integer, got stored over here in the array list. If I want to get this value, inside the array list, I have now one element present, which is 1. Now I want to get it. How can I get it? You can just do like this, right? Array list.get. Can define the index number 0. Now what this get of 0 will give you? An integer value. Why? Because you're storing integers here. If you're going to do command option V here to handle the return type, what it is going to get you? An integer back, right? And if you're going to print out this integer right over here, right? If I want to run this, it's going to get you 1 because this is what you are adding over here. You are adding 1, you are getting 1, right? So no problem over here. But now I have a question here. Can you look into this right now? I have array list of get of 0. What it is returning? An integer. Can I do it this in this way? I'm going to say int I. Okay. Is there any compilation error over here? If you're going to see this line? No, absolutely not. This get of 0 is getting me what? An integer. But where I'm assigning it to what? A primitive int. So compiler is converting this integer, the object type value that we have inside it. Okay, that object, it is assigning it to a primitive integer or primitive int I. And we're printing it over here. So here the conversion happened in the other way, from the object to the primitive type. That's what is happening automatically over here by the compiler, right? And that's what we call auto unboxing. If you're going to run this, I'm going to get I over here. Okay, I'm going to get 1 over here. If you don't understand this, I'm going to give you another example, right? I'm going to come back to this. I'm going to comment it out. Okay. Let's say I have an integer value. Let's say integer I is equal to 10. Okay. Let's say if I'm going to do right now, int number is equal to I. Then what I'm doing, this I is an integer object value. If you don't understand this, I can just do this integer dot value of 10. Right now, this value of is going to return you an integer back. Imagine that's the integer object that you have. It's holding an object of integer. Then this I am referring to this number. Now, this is what? This is what we call auto unboxing. We are just, we have the object over here, integer object. Now we are unboxing that object and assigning it to a primitive number. So converting an integer object to the respective primitive type integer value, that's what we called auto unboxing, right? Automatically, the compiler is doing the unboxing for you. Okay, but if the compiler don't want to do it, if you want to do it by yourself, you can do this. I is what? It's an integer class object. You can just do I dot int value. You can see the int value is returning what? An integer. If you're going to do this, then you are yourself, if you're going to see this integer, it is returning you an int value. You are by yourself converting the integer object value to an primitive int value. Now I can print this as out of number. Now this is you yourself doing the conversion from integer to int. Now this is what we call unboxing, the normal unboxing, right? If you're going to do this, you can see it's just giving me 10 as a result. But if you don't want to do this int value over here, still also things will work. Compiler will do it by itself automatically. That's what we call auto unboxing, right? So if you're going to do this, okay, this should work right over here. Understand this? Now you can think, you can remove this. You can see this example, okay? So get up 0, getting you an integer back, directly assigning it to over here. The compiler is doing conversion, integer, assigning it to int. So auto unboxing, right? But if you're gonna do this by yourself, dot int value, then you yourself converting the integer value to int value, because the int value will get you an integer back. That's what you're assigning. So I can say this is unboxing, normal unboxing. But you understand right now, whether it is compiler is doing the boxing for you or compiler is doing the unboxing for you. The boxing, the auto boxing, and the unboxing, the auto unboxing is kind of similar concepts, right? One compiler is doing, one programmer is doing, right? So I think you understand the difference between boxing and unboxing. But why I'm telling you this story, boxing and unboxing story, right? We read it way back in our college days, or maybe when we began our Java career. Because if you understand this, in Stream, understanding an internal interface or a functional interface provided by Stream API called IntStream, understanding the reason behind it, why they have created that kind of interface or that kind of stream for you, will make sense. Let's just talk about this. And let's just go into a concept called IntStream, or a interface called IntStream, which is an interface or a class. Can I do shift? And I'm going to do IntStream over here. Okay. IntStream is an interface. Yeah, this is an API, right? So I'll just talk about this interface right now, IntStream, what it is. And let's just do a little bit of hands-on on this right now. Okay. Let's just go for it. Okay, so now let's just come back to the Stream API. I have a question for you. Let's say you know about a method called stream off. Okay, what you can do with stream off, you can see this T of values, where T can of any type. So you can basically write any type of objects over here. You can write a string object, employee object, XYZ object, integer object, double object, any kind of object. For an example, if I'm going to write something like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What kind of objects these are? Well, these are not objects. These are primitive type, isn't it? This int type value. Int is a primitive type. But this is expected to take a bunch of objects. Maybe a bunch of employee object, or a bunch of string object, a bunch of XYZ objects or something. But what I'm giving is the int type primitive values. Now, when I do that, what my compiler is doing, internally it is converting each of this int value to integer type of value internally. And if we're going to handle the return type, what this op method is going to do, it is going to get me a stream of integers. We know about this, right? So it's going to get us a stream of what? Integer. What we have given over here? A bunch of primitives. So the compiler internally has converted all of this primitive value to integer type of value and then giving us a stream of integers. Now we can take this integer stream, let's say integer stream, and let's say we can just do a for each, and let's say each of the integer which is coming over here, we can print it. We can just do system.out : println, and whatever this integer stream gonna process the object one by one, we can pass it to this println method, and that's going to print all of the integer value to my console. For an example, you can see all these values, integer objects are over here. Now what the println method is getting over here is an one integer object, right? One integer object we're going to be getting over here, and we are basically doing s out of integer over here. This is what we are doing, right? So the question is, as I said, all these values that we are having over here, all these are primitive int value. So don't you think when you write things like this, the compiler has an overhead? The compiler is doing a lot of work by converting all this primitive value to the integer type value. This may a performance problem, right? If I have many primitive value like this, if the compiler has to convert all these things and then gonna get me a stream of integer, that might be a pretty much problem, right? So I may tell the Stream API developers that this might be a performance overhead because the compiler has to do a lot of autoboxing internally. So don't you think it's a performance problem? I can ask things like this to the Stream API developers. The Stream API developer can tell me like, okay, hold on. So the stream op method here, it can take any kind of thing. It can take a string also. Okay, it can define a bunch of string object over here. Okay, and this can get you a stream of strings in this case, right? It can get you a stream of strings in this case, right? So, but whenever you are giving integers over here, okay, to work with integers specifically, you have something called IntStream. Okay, this IntStream interface is a kind of Stream API interface. Like you have stream.off, like that you have IntStream.off. Okay, so it is still a stream, but what kind of stream it is? It's the int stream. This int stream is designed specifically to handle integer, the primitive int type of objects, not objects, primitive int types of values, right? The int values. For int values things, we can use this off method. And here we can give numbers like this. Now here there will not be any conversion required because the int stream is meant to handle the primitive values. Now if you're going to do command option V like this, it's going to get you a int stream, okay? And you can just do the same thing over here. You can just do int stream, okay, dot for each, and you can take each of the value, each of the integer that you have, and you can pass it to the println. And the println, if you're going to click on this right now, you can see which method is getting called. Int x method is getting called. Println has a lot of overloaded method, right? Lot of overloaded method. Now which method is getting called? Int x, the one which takes a integer as a parameter. Int is a primitive type right now. Previously, if you want to do stream.off, now what it is going to return you? A stream of integer. It's going to return you a stream of integer, something like this. Now if you're going to click on this println method, look which method is getting called? The one which takes an object. So that's the difference, right? So what I told you here, the int stream, if you're going to write here, is going to get you the primitive int value like this, okay? And this int stream is specifically designed to handle the primitive integers value, okay? And this is like a mind-blowing solution. Now you might be telling me, okay, what's the benefit we're going to be getting out of it? A lot of benefits, guys. I'll tell you a thing which can blow your mind. See, whenever you're going to write int I equal to 10, okay, how much memory it will take? Whenever you write int I equal to 10, whenever you are storing any primitive value, here I'm storing all the primitive value, right? So how much, so do you think this is one line? Okay, another line I'm writing over here. Let's say stream of, and let's say 1, 2, 3, 7, 8, 9, 10, and command option V. And this is returning you stream of integer. This one returns you int stream. So out of this line 1 and line 2, which one will take more memory? Listen to this. Int I equal to 10. Let's say, see this line. How much memory this one will take? 4 bytes. If you're going to store any integer value, in the memory, you're going to be occupying 4 bytes of memory, because it's a primitive int value. In Java, we have memory sizes defined for each primitive value. How much int will take, how much double will take, how much long will take, right? Int will take 4 bytes. But let's say if I'm going to do integer I equal to integer dot value of 10. Now how much this one will take? How much memory this one will take? This one will take 20 bytes of memory. This one will take 4 bytes of memory. Why this one will take 20 bytes? Because for the reference, 4 bytes. For the object that it is assigned to, 16 byte. 16 plus 4 is 20 bytes. This one will take 20 bytes, but this one will take 4 bytes. So this line will occupy 5 times more memory than this. So in this case, if you're going to look into this int stream, we are just storing a bunch of integers over here and assigning it to this reference. So obviously this is a less heavyweight object. But if you're going to look into this, here all these objects are internally converted to integer, right? So autoboxing is happening behind the scene, and we're getting a stream of integers. So this one will obviously take more memory. So whenever you are dealing with any primitive value, you work with this kind of interface, IntStream, which basically represents the integer specific value, does the exact same thing. If you want to do any double specific thing, you have double stream, okay? You can just do off and you can give double value over here, okay? Something like this, okay? And this is gonna get you what? Command option V is gonna get you a double stream, and you can just print them out like this, okay? And all the values will be passed to the println and will be printed over here. So I'm going to run this. Okay. Here we are printing the double values. This couple of values over here are from the double stream. Okay. So like in stream, we have in stream, we have double stream, we have float stream. I think double and float both will be go by the double stream. We have something called in stream, double stream, and long stream. Okay, we're going to be talking about all these things later. For each primitive type, we don't have a specific in stream is not available. For integers value, for this integer stream will be working for all the int primitive value and also for the char value. We also have double stream, we also have long stream, right? We're going to be talking about those things. But I think you understand why they have given you this IntStream API when we already have Stream API, right? Is there any other differences? Yes, we have. Let's talk about this. Okay, now let's just go ahead and understand how IntStream is better than the stream of integers whenever you are basically dealing with the primitive int values like this. For an example, we have values here 1 to 10 and we want to sum it up. Okay, then how can you do it? In IntStream, if you are using IntStream to create all this stream of int values that you have, you can easily use a terminal operation. The IntStream interface has a method called sum. Okay, because inside the int, if you're going to click on the sum method, it's present where? It gives you an integer back. It's present where? If you're going to go all the way to the top, is present inside the IntStream interface. As the IntStream interface designed specifically for the primitive int values, it also have a method called sum. And the sum method, if you're going to do command option V, it can give you an integer back that you can directly print it over here. Let's say sum, okay? And if you're going to run this, you're going to be getting the sum of 1 to 10, that is 55, right? Not only this, it can also use something like minimum to get the minimum number of, to get the minimum value over here. I think the mean will get you an optional value. Is it so? It's going to get you an optional int. It's just going to tell you that in the int stream, if there will be values inside it or not, it is going to check using the optional. If you're going to do command option V, it's going to get you an optional int. Instead of returning you an int directly, it is just saying the value may be present or may not be present. This is another Java feature. So we can just do mean over here dot get as int. You can just do this to get the value from this optional int. If you're going to do run this, you're going to get the minimum value out of it, which is 1 over here. That's the 1, right? And if you're going to do max over here, okay, if you're going to do run this, you are going to get the maximum value over here, which is 10, right? So the max or the mean is not going to return you the integer value directly or the int value directly. It is returning you an optional int. It is just saying the value may be present or may not be present. In this case, this max, we are just doing it over IntStream. So we have the stream present over here. We have the data present over here, okay? So that's why we're getting the minimum value out of the data, which is present over here. But most of the time, we can do this. We can just do if, we can just do mean. This optional int is mean. We can mean dot is present, okay? If the value is present, then only get the value, okay? Something like this, okay? So if you're going to run this, in this time, the value is present over here. So you're going to get the maximum value present over here in this stream, okay? For an example, if the stream is empty, okay? If you're going to run this, you are not going to get any value over here, okay? Because it's an optional int. The is present is right now going to be false. That's why this system.out.println will never be executed. But if you're going to remove this, now you're going to be getting an exception. If you're going to run this, you're going to be getting an exception that no value present inside the optional int. Okay, over here in the mean, you cannot just do get int. This one will throw you an exception because this max, you are running it over IntStream and this is empty. Okay, so in that case, this optional int can help you to make sure that if the value is present or not. If it is present, then you can get it by get as int. And for safety, you can have this if clause present over here to make sure that if the value is present, then only we'll be getting the integer out of this mean, which is the reference for optional int. Okay, I hope that makes sense. But that's another feature. We're going to be talking about this optional feature later. But I think you understand right now, inside this IntStream, we have a lot of helpful methods like sum, minimum, maximum, and all these things, right? And in this case, this IntStream can be pretty much beneficial because out of the IntStream object, you can actually do sum or minimum or maximum, or you can do things like this. You have handy utility methods like this, okay? But you might argue with me, okay? So you are saying sum is a method which is present inside the IntStream. Okay, so sum is a terminal operation which is present inside IntStream. So don't you think we don't have any other way to do the sum? Instead of IntStream, if you're going to get stream of integers, can't we do the sum over there? Yes, absolutely, you can do that. There is a way around over there as well. But this is more recommended approach. I told you why. Okay, the IntStream is basically giving you direct methods like sum, min, average, max, that kind of terminal operation. Operation it has. But if you're gonna look in the normal way, for an example, if you're gonna do stream.off, and if you have values like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if you're gonna handle the return type like this, okay, let me just remove the IntStream things right now. Okay, so now Can we find the sum for this? Can we do IntStream? And do we have the sum method right now? No, we don't have any specific sum method over here because this IntStream is an object of Stream API. And inside the Stream API, we don't have any terminal operations like sum, like the way we have it for the IntStream interface. So why don't we have that kind of thing? Because stream of something is stream up something. It can be anything: stream up integers, stream up strings, stream up employees, stream of xyz, stream of your custom objects. So it not only can be integer, it can be anything else. So it's not that generic like int stream, which have functions like sum, because in the int stream we know we're going to be having a bunch of primitive int value that we might have some handy functions like sum, average, minimum, maximum, and the other stuff. But here directly we cannot do sum. But we have some way around to do the sum if you want to do the sum of everything. Okay, how can we do the sum? Okay, let me teach you an approach. There is something called a pattern called reduce. Okay, you can see there is a reduce method. There are three reduce methods, actually three overloaded reduce methods are over here. Let's just take the binary operator over here, the one which takes the binary operator. Okay, so I can just do new binary operator. Okay, and binary operator of integer, and I can override the function that we have inside the binary operator. Okay, so the binary operator is something like a by function. Okay, in the by function we have an apply method which takes couple of input over here. Okay, which can be of any type, and the output can be of any type. Okay, the by function has been extended by the binary operator. What the binary operator is saying, you can see it is TTT. That means the inputs are going to be the same type. The output is also going to be of the same type. For an example, here whenever we are, if we're going to close this, over here inside a reduce method which takes a binary operator, if you're going to see this method that we are overriding is apply, but the input is going to be the integer. The output is also going to be the integer. That's what the functionality of binary operator. The input will be of same type, the output will be of same type as well. So right now, what you can do, you can just do, let's say integer 1 plus integer 2. You can just do it over here. Integer 1 plus integer 2, something like this, and return this. Let's just see if that works. If you're going to run this, oh, we're not getting any value because we have to handle the return type. Something like this. Okay, it's going to get us an optional value. Okay, optional of integer, because the reduce method, if it is applied over an integer stream, this integer stream, if these values are null, then we might not have any value present, right? So we have an optional of integer, so we can just check if what is this? Reduce. Let's say I'm going to say result. Okay, if result dot is present, okay, if the value is present, then I'm going to get the value and print it. I'm going to say sout result dot get. Okay, and if you're going to run this, I'm going to getting the sum of 1 to 10. Okay, but how does this work? How does this reduce function works? Okay, now let's just understand how this reduce method works. What is this reduce? Reduce means in a stream we have number of elements. Like this, in this stream we have number of elements. Now we're going to reduce it to one element. We have to reduce it to a final value, right? How? For an example, you have 1 and 2. Okay, you have 1 and 2. These are the initial two values. Here in the reduce method, we are taking couple of parameters as integer 1 and integer 2. So first 1 will come as integer 1, 2 will come as an integer 2. We're going to be summing them up. 1 plus 2 will be 3. Then the integer value 1 will be 3. Then the next value in the stream will be 3. Then 3 is the previous value. 3 is the next value. 3 plus 3 will be 6, right? And then 6 will be now the new integer 1 value. The next value will be 4. Then 6 is the previous value. 4 is the current value. 6, 4 is equal to 10. So integer 1 value will be 10. Like that, it will be reduced to 0. I'm going to tell you. Let's not get confused. Okay, we have these values, right? How this reduce pattern works. If you're going to understand one, all the three methods are going to be super easy. Okay, so let's say we have this value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have to reduce it to one value. How can you do it? So these are our first two value. Okay, if you're going to sum it up, 1 plus 2 equal to 3. Rest of the value will be exactly same like this. Okay, now, okay, don't treat it in a stream way. Just see how it works. Then we're going to be understanding how that stream functionality is working in that method. Now let's just understand the stream pattern. Okay, again, we're going to be summing this 3 and 3. Okay, this will be 6, and the rest of the values will be exactly same as this. Okay, now what is the next value? 4. 6 plus 4 is what? 10. Okay, then 4 we have already used. These are the next values over here. Now 5 is the next value. 10 plus 5 is what? 15. We have used 5. These are the next value right over here. Okay, now 15 plus 6 is 21, and these are the next value that we have. Control C, paste. Okay, 21 plus 7 is 28. 28, and these are the next values that we have, right? And then 28 plus 8, 32, 36, by the way, over here. Then it is 9 and 10. Then 36 plus 9 is 45. 45, 10, and if you want to do it, is 55 will be the final value over here. Okay, this is how you have reduced the value to 55 over here. And if you're going to see exactly in the same way, the things will happen over here. So if you don't understand this, you can have the log for it. Okay, you can have a s out, and you can print the integer 1 value over here. You can also print the integer 2 value over here, and then you can have a equal to sign over here. Then you can actually print the integer 1 and integer 2 value. Just for demo, you can just do integer 1 plus integer 2 over here. Okay, let's just check like how the flow goes. The integer 1 value will be 1. The integer 2 value will be 2 at first. Let's just see if you're going to run this. Okay, you can see how this goes. We have integer 1, that's 1, that's the first value. Integer 2, that's 2, that's the second value. The result is 3. Okay, now 3 will be the new integer 1 value. There you go. Then integer 2 will be the next value from the stream, that is 3. Then 3 and 3 will be 6. Okay, then 6 will be the new integer 1 value, right? And then the next value in the stream is 4. Okay, 6, 4 is 10. Then 10 will be the new integer 1 value. Then the next value will be coming. At first, 2 integer value are expected. 2 values will be flowing from the stream, 1 and 2. Then 1 by 1, 1 by 1, 1 by 1, the value will be coming. Okay, if you don't believe me, you know how to prove it, right? How to prove it? Use a pick. Okay, I can just do a pick. Okay, and pick will take a consumer, take the number which is coming on the stream, and I'm gonna do s out over here. S out. Come on. Okay, the lambda symbol is not correct. Do a s out, and I'm gonna just print the number, and I'm gonna say picking or something, and I'm gonna say number for the log. Okay, just want to see how the values will be picked one by one from the stream. As I said, first it will pick 2 values, 1 and 2, and that will be passed to here, integer 1 and integer 2, and then they will be summed up. Okay, if I'm gonna run this, okay, you can see first it is picking 1. Okay, then let's just keep a space over here. Okay, so you can see the value properly. You can see picking 1 and picking 2. So now the integer value will be 1, integer 2 value will be 2. If you're going to sum it off, it is 3. And after that, it's going to pick the next value in the stream, 3. Okay, so whatever the result, that's the integer 1 value. Next value which is picking from the stream, that's the integer 2 value, and that will be 6. Okay, next one, it will be picking 4. 6 will be the new integer 1 value. 4 is something which will be coming over here. Then it will be 10, and it will be keep on going, right? So you just need to understand the flow over here. But right now, I'm gonna do a little bit of modification over here. The pick I will remove because you understand how it works. Okay, the reduce method is takes a by function, And in the by function, the apply method, we can just convert it to lambda. We can remove everything, the binary operator, the new keyword and everything, and we can convert this to lambda. We can convert this to lambda like this, and we can remove one more brace from here, and we can get it to this line. Okay, so this is going to be your final output. Okay, and you can also remove the type of this integer types, and you can actually modify it more, something like this. Okay, and actually if you want to get rid of this logs and everything, you can simply take this to one line. You can also remove return and take this to one line like this. Okay, and also you can get this to one line like this. Okay, so that's your reduce function that you have, which is going to get you an optional object, right? This takes a by function, takes a couple of integer value, summing it off, and you're doing the thing. Okay, guys, one more thing I want to ask here. What you are doing, you are just taking couple of integer value and then doing the sum. Okay, so you are basically giving the logic for what? For the by function. Okay, you have that whatever this reduce method had this binary operator. Okay, this binary operator is another functional interface. Okay, so binary operator extends from by function, and for this apply method only, you are giving the implementation, right? You are basically accepting two integer and returning an integer back. Okay, so you are basically need to do the sum up. Okay, so do we have any existing method which basically does sum up internally? Do we have any pre-existing method? Of course we have, right? We have a method called sum, right? So instead of doing the logic by ourselves, the summing up logic, I can do this, right? Integer dot sum, and I can pass the integer 1 that I'm capturing and integer 2 that I am capturing, right? So the sum method from the integer class, the static method of sum from the integer class, I can reuse over here. Or I can do one more thing. These are two values I'm accepting, which will be this value and this value first, and then I'm passing it to the integer class sum method, which is present over here. Okay, because it has the same logic. I'm reusing the method, right? So if I'm going to reuse the method, if I'm going to pass a couple of parameters, then also we have method reference. By using what, you can also do some shorthand, right? You can also remove these parameters, right? Something like this. You can completely remove this thing, and you can completely remove these parameters over here. You can call the sum method directly by using the double colon operator. Okay, now see how simple is that. If you're going to run this, you're going to get the exact same result, right? You're going to be getting 55, right? So now to the sum, first this couple of parameters will be passed, and it will do the sum. And once we get the final value, the first parameter for the sum over here, the first parameter for the sum will be the summation of the first couple of value, and then one value will be keep on getting from the string. The exact same concept that I have told you. So if you know method reference, this will even it will be more easier for you to understand. But in case you have not completed my method reference video, you can revert it back to the other way as well. But this looks more cleaner, right? And this is how the reduce method works over here. Okay, I just want to give you one more example of reduce method, the way it works, before we proceed to the next section. So here we have seen the reduce method, which basically takes couple of input here. We can take couple of input, and then we can just sum them up like this. And this actually works. Okay, we also have the reduce method, which takes a initial value if you want to do it. For an example, instead I wait for the first two value to come over here, and we'll be replacing this a and b, then we can sum them up. Then the new result will be the value of the first operand over here. Instead of that, for this first parameter, I can actually supply a value. For an example, for summation, I can supply a value like 0 over here. Okay, I can remove the return type for now. Okay, I can remove this for now. Okay, for the reduce method, the initial value, the seed is 0 right now. Okay, that means this 0 will be passed to this a, and the b will get the value from the first element from the stream. This is 1. Okay, now 0 will be the a value, 1 will be the b value. Then 0 plus 1 will be 1. 1 will be the a value. Second value will be getting from the stream, which is 2. 2 will be the b value. 2 plus 1 is 3, right? So now 3 will be the a value. Next element, 3. 3 will be the b value. 3 plus 3 will be 6. Then 6 will be the a value. Next element is 4. 4 will be the b value. Now that will be keep on continuing. So 0 will be first replaced with a. Then we're going to be getting one value from the stream, and that will be keep on going, right? So if you're going to do run this, this will also give you the exact same result, right? If you're going to handle the return type, Command Option V, handle the return type over here, it's going to get you a integer value. You can directly print reduce over here. If you're going to run this, this is going to get you the exact same result, right? Cool. Okay, so if I'm going to do this, what will be the output? Okay, if you understand how this works, just let me know what will be the output in the comment section, okay, for this. So 0 will be the first value which will be replaced to this, okay? Just understand this and just let me know what will be the output of this in the comment. So we understand stream of integers, like, this is something more generic, okay? But to hold primitive integer value, we can actually use the IntStream. We understand that already. Now, I have few questions. I will tell you, let's say we understand these two things, stream of integers, okay? And we also understand something about IntStream, okay? IntStream is specific for primitive integers type, and this is for storing the integer objects inside the stream. But there will be places where you will be needing conversion from stream of integer to IntStream, and maybe from IntStream to stream of integer. And we will be understanding that, how you'll be doing that conversion, okay? So to give you some examples, okay, we'll see some boxing and autoboxing thing again one more time, okay? Just have your concentration over here. So I'm going to remove everything that I have here, apart from that reduce thing over here. So I have used reduced method here, because on top of the integer stream, as it is a stream of integer, as it is holding the object of integers, I actually cannot use the sum method over here. Okay, can I do sum over here? No, I don't have an inbuilt functionality of sum, because the sum doesn't, it's not present over here inside the stream API. So is there any way I can use the sum method over here? Yeah, the way will be pretty simple. Until and unless we can get an in-stream value or in-stream object out of this integer stream object, then we can perform the sum method. For an example, we have a stream of integer, okay? If we can convert it to int stream, then inside the int stream, we have the sum method, and we can call the sum method on top of the in stream object. But now the question is, how this integer stream can be converted to int stream? Is it possible in the first place? Okay, so I have a question. Now, if you have an integer, for an example, can you convert it to int? Can an integer can be converted it to int? Obviously, an integer value, we can place it inside the int value. Okay, that's what we called unboxing or auto unboxing, right? We can do this. Let's say we have a integer I is equal to 10. We can actually do int number is equal to I. That's possible, right? I is an integer value. We can assign it to int number, right? And that's what we call auto unboxing, right? So we are basically converting the object type integer value to the primitive type integer, right? We already spoke about this. Now, if this is possible, this is also possible, right? We have stream of integers. Can we convert it to a int stream? Okay, absolutely, that's possible. So how to do that? Okay, inside this integer stream, now what will happen? One object will come. As I told you before, stream of integers holds all this value. So internally, the compiler will convert all this value to integer object, right? And one object will come, like 1 will come, and then 2 will come, then the 3 will come, and it'll go like that. Let's say once one value will be coming, there is a method here called mapToInt. Okay, we can use this method for the conversion. If you're going to use mapToInt method, as the name says, mapToInt, what is coming here? Integer in the integer stream, a stream of integer, one integer object is coming. Now I'm going to take one integer object, then convert it to the primitive int. Okay, and like that I can take all these integer objects, then can convert it to IntStream, because the IntStream can contain all these primitive integers value. That is possible by using this mapToInt method. If you're going to go inside this mapToInt method, you can see it takes an input called ToIntFunction. Okay, don't worry much. You know about function, right? What is function? It takes an input, gives you an output back. Okay, ToIntFunction means it takes any kind of input, but always give an integer back, a primitive int back. Okay, so ToIntFunction is a internal functional interface they have created for us, which has one method, whatever it is, apply as int, which takes any kind of value, but always going to give an primitive int back. Okay, so we can utilize this apply as int method over here. So can I go back over here to the mapToInt, and can I just create the object of ToIntFunction, and we can override the apply as int method. It takes a value right now. What value we are accepting? We're accepting the integer value. Obviously, in the integer stream, one value will come, and these are internally getting converted to integer object only. So we are holding a stream of integer. So one integer will come. That's what we'll be accepting over here. And what we will do, we will be returning that integer back. We cannot, we don't need to do anything else. We can directly return it back. Now, whenever we're returning it back, where we're assigning it to? We're assigning it to an int. So when accepting an integer, let's say integer object, then returning an int back. Okay, so we are just doing this. Okay, we are doing int, let's say int value is equal to, let's say one integer object will be coming over here, something like this. Let's say integer object will be coming over here. Let's say new integer. For an example, is deprecated. This constructor is deprecated, but you can think like this. Let's say you have one integer object is coming, but what we're returning? We're returning a value back. Okay, we're assigning that 10 to this int. Okay, now you can understand, right? One integer value will be getting, then we'll be returning the int value, right? So if you want to see the return type of this, Command Option V, see what it is returning. It is returning a int stream. Okay, now I can see the beauty of mapToInt. Okay, one integer object it will accept. Okay, then what it is actually going to return a int value. So here you are not doing anything, you are returning the value directly. The compiler is going to do the auto unboxing. It is going to accept the integer value, convert it to the primitive int. Okay, then like that it is going to convert all this integer value to primitive int and going to return me the IntStream object, right? So then you can actually do IntStream.sum. Okay, so sum I'm calling on top of what? IntStream. How did I get the IntStream? I call the mapToInt method on top of the stream of integer. So the stream of integer can be converted to IntStream by using the mapToInt function. We can unbox the integer to int type. Okay, then can do the sum, and you can print it out. You can just do s out, and you can actually print it. Okay, nothing fancy over here. If you're gonna run this, it should give me 55 as a result. I think you understand this, right? Now, some people can ask me, okay, Vilas, you are doing it. So the compiler here is taking the integer value and assigning it to an int, okay, and returning an int. So automatically the conversion is happening. Can I do it by myself? Obviously. How can you do it by yourself? I have already told you the method that you can use. Value is an object of what? Integer. So is there any method which can help you to convert the integer to int? Yes, int value method. You can do it by yourself also, but the result will not vary. If you're not going to even write it, the compiler is automatically going to assign the integer to int. Otherwise, you can do it by yourself. The result is still 55, but here you are just getting the int value out of, because the int value is going to give you int back. So you are getting the int value out of the integer and returning it, right? So I think you understand what this map to int means. So you can actually reduce this. How can you do this? So you'll be seeing you can reduce everything, the code over here. You can keep the lambda symbol over here. You can remove the extra brace over here. You can take it to one line like this. You can take this to one line like this. You can also remove the return out of it. Okay, because this is what we are returning. You can also remove the extra brace. You can also remove the type. You can also remove the brace over here. Okay, see, you are getting a value and you are returning value dot int value, right? If you want, you can also do this. Okay, well, you are getting a value and returning the same value back. But as per the signature, this value will be a int. Okay, because this is the implementation for what? Sorry. This is the implementation for what? This is the implementation for the map to int, okay, for this interface, okay? And this interface giving you back what? An integer, okay? So by default, that will be converted to integer if you're writing like this, okay? Or if you're getting confused, you can always do int value over here, getting the integer object, but converting it to an int type and then returning the IntStream, because the map to int will return an IntStream. Okay, or what you can do here, what you are doing, you are getting one integer, and that on top of that integer you are calling the int value method. If you are converting it to method reference, you can also do the things you already know that in the integer class. Okay, you have a method called value of, and value of is not a static method, it's an instance method. Okay, you can see here, value of is a value of not the value of method. Sorry, I can call the int value method. Okay, int value method, and int value method is an instance method. Okay, you can see it's an instance method. Okay, if it is an instance method, this will get me what? This will get me a int back, right? So integer colon colon int value. So whatever integer object will be coming, now let's say one integer object will be coming, okay, over here. Now on top of that integer object, int value will be applied, okay, and whatever the output will be, that int value will be given to the IntStream. Like that, for every integer object, on top of every object, this integer will be replaced with the object which will be incoming. I have told you that in the method reference video, right? Whatever the object will be coming, on top of that int value will be applied, okay, and the respective int will be given back, and I'll be getting the complete IntStream like that only. Okay, and on top of that I'm calling the sum method. Now as you understand everything, I can actually replace this thing to this, right? I can do this. Let me just remove everything. This will get me a stream of integer. Then I can convert it to IntStream, and then I can actually call the sum on top of it. Okay, something like this. Okay, and I can remove everything that I have over here. And this is the shortcut thing. I can do something like this. You can see it returns a stream of integer. This returns a IntStream. Then I'm summing it up, right? So stream of integer to IntStream. This is how I can do it, right? Map to int method. Remember that. Even if you are feeling confused, you can just do value and return value. Okay. Okay. Now this is the auto unboxing thing. Let's just talk about the boxing part. All right, so now we understand how to convert stream of integers to IntStream. Now let's just understand the boxing part. How can we convert the int stream, the primitive value, to stream of integers, to the object type of integers, right? Let's just talk about that. So int stream to stream of integers. Can we convert this? Of course, yes. You'll have requirements like this. Let's just see how we'll be doing it. For an example, I'm going to give you example only. Okay. So first of all, let's just create a int stream so that we can try converting it to stream of integers later. But let's just try to create an int stream. I have told you how to create an int stream using the intstream.of method. Now you can also use something called intstream.range method. Okay, there is two methods actually. Range, you can give range over here 0 to 10, something like this. Now it will help you to create an integer stream, or a int stream, not integer stream. I'm wrong. Int stream, primitive type, 0 to 10 value using the range method. There are two methods, range and range closed. Let's just use the range method first. If you're going to do command option V, it is going to get you a int stream of range. I'm going to say int stream over here. Can I call the for each method over here and try printing each primitive value that I have over here? Can I just say system.out : println, and let's just try to run this. Okay, what I'm going to get over here, I'm going to getting the value. But see how many values that we have? 0 to 9. But I've given the range here 10. So whatever the value you are giving, that is excluded, right? That is excluded. Right now it is printing from 0 till 9. It is not printing the actual 10 value, right? So that's how the range method works. But if you're going to write range closed, okay, instead of range, I'm going to write range closed, then I think this will be included. Okay, if I'm going to run this, it's going to help me to print the value from 0 till 10. Okay, that's the difference between range and range closed. Let's say I'm going to use the range closed method to create an int stream, which will help me to create an int stream of 0 till 10. Okay, I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 till 10. I have an int stream like that. Okay, now let's say I have a requirement. So what I'm doing over here, I'm taking each of this primitive value which is coming, let's say each of the number which is incoming, then I'm actually printing it over here, printing the number, right? And obviously this println is obviously the int x we are passing. Obviously the primitive values are coming and we are passing it over here. Okay, now I have a requirement. For an example, stupid requirement, but I have a requirement. I want to apply the hash code method over every integer which is passing inside. Can we do it? I just want to do it. I just want to let's say I want to use a map method, okay, or something. Map method on this int stream. I want to use the map method, okay, and here I want to capture every number and I want to do what? Number dot hash code. I want to find the hash code of each number. Is it possible? And then I want to print the for each. For every hash code, I want to print it over here. Okay. Now, every number which is coming, I want to convert. I want to find the hash code and I want to return it. Right. So can we do it? Can we do this? Now, what I'm doing is over here is this. I have started it and I will be returning this, and then on top of this I will call the for each method. Okay, so and I'm going to say it's, let's say the hash code I'm getting, and I'll be printing the hash code. Now you already, if you understand stream, you should be already scolding me that Avilas, what you are trying to do. This hash code I'll be receiving and I will be printing over here. Okay, now the thing is, I'll remove this dot symbol over here. Now look at this. Okay, now you tell me whether this is a valid piece of code. Now number which is coming over here, that will be 0 to 10, 0, 1, 2, 3, it is coming. Now these numbers are primitive numbers or integer. Okay, these are obviously the primitive numbers because as I said, int stream represents primitive numbers, right? So 0 to 10, obviously the primitive values will be coming over here. Now, on top of the primitive value, can you apply hash code? Of course not. Okay, you cannot actually apply a hash code on top of the primitive number. That is impossible. So, in a way, what I want to do, I want to convert each number which is coming to me. Okay, I want to convert it to integer type, okay, to the object type. Because if I have an integer object, I can call the hashcode method on top of it, correct? Right? I cannot do 10 dot hashcode. I cannot do this, right? Maybe this is not a valid place to write it. I cannot write 10 dot hashcode. I cannot do that, right? But if I have a integer value, let's say integer dot value of this, let's say I have 10, then on top of this, I can call the hashcode, right? Because what the value of method is going to return is an integer object. That's what I want, right? So how can we do that? Okay. So now this IntStream that is coming to me, if I'm just going to use one thing here called boxed, then my problem is fixed. You can see right now, this is not going to give me any error. And if I'm going to run this, right, it should print me the hash code for everything. Okay. You can see it's printing me the hash code of 0, hash code of 1, hash code of 10. I think the hash code of everything is just the value of that, right? So if I'm going to run this, you can see this is what the result that I'm getting. Okay. Now the question is what this boxed is doing over here. What this boxed is doing over here. If I'm going to terminate my line over here, and IntStream is the integer stream. If I'm going to apply boxed over here, if I'm going to do a command option V, look what it has returned to me. It has returned me a stream of integers. Okay. Now previously I have some bunch of primitive streams. Okay. But using the boxed method, I'm doing the automatic boxing. I'm doing the autoboxing. I'm converting each primitive value which is present inside that IntStream to stream of integers. Now this stream of integers here, okay, now this will be one integer object that will be processed, right? If I'm going to copy and give it to my map, now my map is going to apply it on this number which will be one integer value, right? One integer object. Okay. And on top of each integer object, I'm calling the hashcode method. That's perfectly valid, right? So understand the boxed method. So anytime if you have a requirement to convert the int stream to the integer stream, then you can do it in this way. For an example, one more thing I can show you over here. So you tell me what will happen over here. Let's say I have int stream, okay, and if I'm going to do collect, okay, and I'm going to collect everything. Let's say I'm going to say collectors dot to list, okay, then if I'm going to end it over here, you can see we're already having a problem. What we're saying that we are trying to collect all this primitive value and we want to store it inside a list, but this is giving us a compilation error because the collectors.toList, what this collect method does expect, okay, over here it expects some kind of object type, but what we are having here, the int type. Okay, now can we convert this to some object type, this int type? Yes, we can do it by using boxed. Now I can see this int stream now converted to stream of integers. Now all these integers right now, I want to collect it and I want to put it inside a list. If I'm going to do a command option V, and if I'm going to handle the return type, what I'm going to get over here is a list of integers, right? So out of the primitive value I've converted to the stream of integer, then all this integer I'm collecting over here like this, right? So I can just do s out list of integers, right? If I'm going to run this, you can see all my integer objects over here. These are all integer objects, right? I hope you understand how this boxed method can help you to do the conversion. All right? All okay? Good. Okay, so that's it for this video. We will be jumping to parallel stream right now, but before we jump down, I have a question for you. Okay, a very simple question. Look at this. What I want you to do, I want you to do this exercise by yourself and let me the answer in the comments. Let's say I have an integer array, not like this. Okay, question for you. Okay, let's say a new integer. Okay, and then I have some bunch of values. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I'm going to do this, arrays dot stream, okay, here I can basically pass a long double T array, right? So if I will be passing this integer array to this, what it is going to return to me? Okay. Is it going to return me a stream of integers or an int stream? Okay, try this by yourself. What this method will return to me. Then you mention in the comment that Abhilash, this will return a int stream or a stream of integers to me. Okay, you test that by yourself. Okay, because this is another way to create a stream. I just want to know the arrays.stream method. Whenever we pass the integer array, what does it returns, right? You might have noticed while I'm typing only, but you do it by yourself. And also I have a question. If I have a int array, not an integer array, I have an int array, okay, something like this. Let's say new int of this, and I'm going to pass this int array over here. Then what this is going to return? This is going to return an int stream or an stream of integers. Also test it out by yourself and let me know in the comments. That's the assignment for you for this video. And you do hands-on. There are some other types like double stream, like IntStream we have double stream, we have float stream. Float stream we don't have. Like float stream and double stream are one. Double stream can do that work. We have I think long stream. Okay, char stream also we don't have because chars are basically integers. IntStream can do that work for you. We're going to be talking about that in our in our next lessons. But in our next section, we're going to be talking about the parallel stream. We're going to be using this IntStream and the reduce method a little bit in our parallel stream, the sum method a little bit in our parallel stream. So do some hands-on with this and just come back in the next video. Okay, so watch the next part of this video then. Okay, that's it for this video. Thank you very much. Have a good day. Happy coding. Practice, subscribe, like, comment. That's it. Bye-bye.